Okay, so let's talk about our geometric sequences and series now, and take a look at how they're different from the arithmetic sequence and series we just talked about. So geometric sequence is basically where instead of adding the same number each time to get to the next term in your sequence, you're going to multiply by the same number each time. And so what that gives us is a common ratio. So it says, the official definition, the ratio r of successive terms is always a constant, or the same number. So we take a common ratio r instead of a common difference d when we're looking at these things. And to figure out what your common ratio is, just take one term and divide it by the term directly before it. So for this example, if you have the sequence 2, 6, 18, 54, it's very clear here to see that you're multiplying by 3 each time, and that's going to be your common ratio. But if it's not clear, following this rule, we could take 6 and divide it by 2, or we could take 18 and divide it by 6, or we can take 54 and divide it by 18. Any way you do it, you're still going to get 3. Okay, so going through and doing our analysis like we did before, if the second term of our geometric sequence is the first term multiplied by r, we can say that the third term is the second term multiplied by r, but then replace a sub 2 with what we just got here, and we actually get it as a sub 1 times r squared. Okay, a sub 4, you're going to do the same thing where it's the third term multiplied by your common ratio, but our third term we just evaluated as a sub 1 times r squared. So you plug that in and you get a sub 1 times r cubed. So just like before, we can look at this and analyze it and figure out a formula for figuring out the nth term of your geometric sequence or series. And as you see, we're always starting with the first term, always multiplying by r, but r is going to be raised to a power that is always 1 less than n. So that means that our formula is going to be to take a sub 1 multiplied by r raised to the n minus 1. Okay, so let's try it out. We're going to find the 8th term of the geometric sequence. 1, 2, 4, 8. So looking at this, first of all, what is the common ratio? The common ratio is going to be 2. We're multiplying by 2 each time. So we're doing a sub 8 is equal to the first term, 1, multiplied to the common ratio, 2, raised to the 8 minus 1. And this is where your scientific calculators are going to come in handy, or you can just multiply that out by hand if you want. And we get 128. Okay, so we had arithmetic means before, now we get geometric means. So geometric means are simply the same thing, it's just the terms that are in between two other terms of a geometric sequence. So you're going to have the same kind of problems where they say find a specific number of geometric means between any two numbers in a geometric sequence. So in this case, we're going to say find 3 geometric means between 64 and 4. We are going to set up the problem exactly like we did before, starting with 64 being the first term, 4 is the last term. There's 3 terms in between because we're finding 3 geometric means. And we can set up our equation saying that 4 is going to be the 5th term of this sequence. So 4 is equal to 64, the first term, times r, which we don't know yet, raised to the 5 minus 1. So we'll go through and solve this for r, isolating r to the 4th and then taking the 4th root. But when you take the 4th root, remember you get plus or minus 1/2. So what that means is there's actually going to be 2 sets of these geometric means. One set is if your common ratio was 1/2. The other set is if your common ratio is a negative 1/2. Okay, so let's do the first one where if it's a positive 1/2. You can fill this in. You get half of 64 is 32, half of 32 is 16, half of 16 is 8, half of 8 is 4. You know you got that right. Okay, but what if your common ratio was a negative 1/2 instead? Well, if that's the case, you're going to get a negative 32 here, positive 16, and then a negative 8. So in geometric sequences and series, your sign can go back and forth between positive and negative if your common ratio is a negative number. So just keep that in mind. All right, so now let's talk about geometric series. We'll say the sum of the terms of a geometric sequence, obviously, and we want to look at the formula to calculate out the sum of a geometric series. It's a little bit more complicated, a little messy, but we can still deal with it. You're going to take the first term and multiply it by the quantity of r raised to the n minus 1. So this is where people get a little confused, because this exponent is simply n, not n minus 1 like we had in the other formula, right? And then don't forget to divide by r minus 1. Okay, so this one you're just going to have to be really careful, write things out neatly so you're not getting confused about what's exponents and what are not exponents. Okay, because I see that happen a lot. All right, so let's test it out. It says find the sum of the first 8 terms of the geometric series, 6 plus 24 plus 96. All right, so first of all, let's figure out what our common ratio is. 24 divided by 6, we get 4. Our first term is 6, and we are taking this out to 8 terms. So we can go ahead and plug everything in. There's our a sub 1. Here's our common ratio raised to the n minus 1 over our ratio minus 1. Yes, it's a big number. So we'll work it all out, and we get 131,070. All right, so that is your geometric sequence and series. Not as bad as we thought it would be, right?